All right, so another one of those multi-step things. Let's try this one. Ethane gas, which is C2H6. All right, at least they gave us the formula for this. C2H6 gets burned with oxygen gas. And remember, oxygen is one of those diatomic elements. By the way, I'm going to put the little G down there, signifying that we're dealing with gas here. So I'm adding these two together. And keep in mind that there's going to be a number that comes out in front here that I haven't written in yet because I haven't figured it out yet. All I'm trying to do is get the chemical or the compound names into their formula versions. Over here I have carbon dioxide gas. All right, so CO2 gas. It's pretty well known. And I've got water. It's probably the most well-known formula. And at least they told me it was liquid water, so I'm going to put a little L there. Oh, okay. Well, I think all of this, all that matters here is just balancing the equation. Now, my trick for balancing this equation is this. When I'm dealing with something that looks like you're adding oxygen in, and they say it's burning, and you have CO2 gas and H2O liquid coming out, essentially what we call that is a combustion reaction. And what I always do is I always deal with the oxygen last. So I'm going to deal with the carbon, I'm going to deal with the hydrogen, I'm going to deal with the oxygen last, and I'm going to use this freaky fraction method that a lot of people don't like, but then yet it's probably one of the most powerful tools that you can use. All right, so dealing with the carbon, let's see, that was C2H6. All right, yeah, I just kind of wrote it down a little ugly. All right, C2H6. So on the left side there's 2 carbons. On the right side there is 1 carbon. So I'm going to put a 2 here. And that would make 2 carbons on the right side and 2 carbons on the left side. Now I told you I would deal with oxygens later, so I'm not going to worry about what's going on with the oxygen just yet. And I'm going to deal with hydrogens. Now there is 6 hydrogens on the left side, which makes me want to put a 3 out in front here. Because there are 2 hydrogens on the right side, and then you multiply that by 3, you end up getting 6 hydrogens. So as far as the carbon and the hydrogen goes, this thing is balanced. Now the problem here is on the left side we only have 2 oxygens, and on the right side we have, all right, so how many oxygens? Oxygen has 4 from here, and it's got another 3 from here, so that's 7 altogether. On the right side there's 7 oxygens, on the left side there are 2 oxygens. Now that's a little weird. Now if on the right side it had 6 oxygens, let's say some even number, then actually this thing would actually be really nice, because since this oxygen comes in pairs like that, then all I need to do is just multiply it by like the number 3, and that would bring that up to that even number. The problem that I have here is I'm dealing with a odd number on the right hand side. So I'm going to use that fraction trick. I'm going to multiply this guy by 7 halves. And the reason why I'm doing that is because, all right, essentially this divide 2 cancels out with that oxygen 2, and that kind of gives me oxygen 1 essentially, and then I multiply that by 7, and so this is technically balanced, although it's not. I say it's technically balanced because it's kind of a mathematical thing, but at this point chemists don't like fractions as a coefficient, and I totally understand why. So we're going to clear out that fraction by multiplying everything in this by the number 2. So I'll put a 2 here, a 2 here, a 2 here, and a 2 here. Now writing that out, I end up getting, let me just write it nicely, 2 C2H6 gas plus 7 O2 gas yields 4 CO2 gas plus 6 H2O liquid. All right, now that the dust has settled, let's see if everything's balanced. CHNO. CHNO. On the left side, I have a total of, it looks to me like 4 carbons. On the right side, I have 4 carbons, because that 4 distributes out to there. On the left side, I have a total of 12 hydrogens, I think. And on the right side, wait, no, hey, you have to get, no.
Wait.
Sorry about that, folks. My son needed water. Okay. Instead of trying to re-record this whole thing, let me just finish this off. So as far as hydrogens go, on the left side we have 12. On the right side, I think it's pretty obvious we have 12 because we have 6 times 2. So there's a 12 there. Now, as far as the oxygens go, there are 14 I see because there's 7 times O2, and so there's 14 here. On the right side, there is, let's see, there's 4 times 2, which is 8. And then I have another 6. 8 plus 6 is 14. Awesome! This, my friends, looks like it is the balanced equation. I hope that helps. Let me go grab some water for my son, and I'll be right back.